The heart of almost any application is its database. The performance and features of your database will be either a limiting factor or a launching point for your application. Today, we're going to be looking at RavenDB, a multimodal NoSQL database that auto-indexes your queries, can track changes to your data, and that returns your queries in milliseconds while being ACID compliant. Oh, and it can run on a Raspberry Pi. Now, in this video, I'm going to give you an overview of what RavenDB is before we jump right into the code. In just a few minutes, we'll have a database up and running, and we'll be performing full CRUD operations on it from C#. And along the way, we'll look at auto-indexing, change tracking, working with Aspire, and more. We'll also discuss the pricing around RavenDB, and the good news is that for developers, it's free. You can also get a free community license to start working in production with RavenDB. Now, this video has been sponsored by RavenDB, so I want to explain what that means. I only take sponsorships where I believe in the product and I believe it would benefit my audience as well. Basically, I take money from vendors to create videos that I would have created for free. RavenDB is no different. As you will see, it's a great database with a lot of great features, and it also integrates well with .NET. So you as a viewer get a video with even more content than normal, plus you get some extras. In this case, you'll get a $200 credit for the cloud if you use code IamTimCorey. The details are in the description, and if you use the link below to download the source code, I'll also email you the details to get the free cloud credit as well. So let's jump right into looking at RavenDB. A good place to start is ravendb.net. This is the page where there's a lot of information about RavenDB, including the documentation, which, by the way, when I talked to the developers, one of the first things I said was, I love your docs. They're so good. There's lots of great stuff in here. They're really helpful for reading through and understanding the various parts of the system. Now, there's also AI tools for helping you understand the docs, helping you understand in context. We're going to talk more about that. Just a quick note. One of the first things I talked to them about when it came to my concerns or questions that I had was about AI. And I said, I don't want an AI that's looking at my production data. And that's not what happens. So the AI is only allowed to see what you give it a connection string to see. So it's not going to be accidentally looking at your production data. So that's a really important point for me, was that it didn't start kind of peeking at things it shouldn't. I recommend that you only ever allow the AI to look at most, scrubbed developer data. Scrubbed dev databases, that can be fine, but don't give it access to production. That's my recommendation. It's more useful for helping you work with RavenDB and helping you configure things, but otherwise, I would not allow it to access your data necessarily. Now, there are potential exceptions to that. And one of them is the fact that you can integrate Gen AI into a background worker, so that when data comes in, let's say you have data come in and you want it translated, you could have that record go right to the Gen AI. It could translate it and put the translation in a field. That's potential. You got to be very careful, though, to make sure that you have some really good protections around what it can and can't do. It can also work on external things like attachments to the database. You can do file attachments. It could process those file attachments. There's other things it can do in Gen AI. You just need to be really, really careful when it comes to production data, that you don't have an AI that could go rogue or could be prompt injected. So be very careful of that. Okay, so on here, as well as the pricing, real quick, you can do installation using Docker. You can do, which we're going to do today. You can do installation using Aspire, which I'll hopefully demonstrate today. We can do installation on-prem, which means your own server, and then you just pay based upon the cores. And the last option is you can install via the cloud. You have the cloud version. So pricing, I would encourage you to look through this because there's different pricing models here. But the important part here to me is not the pricing. Because notice it says contact us. That's just because it's based upon a number of cores of your machine. And so it's going to change. But the important part for me is all the things here on the left that it allows us to do. right? These are all the features. And notice how many features there are. This is a great way to come in and say, hey, what other features does this database have? Because there's so many, you can come and look and say, hey, let's learn more about RavenDB ETL and learn more about what that does, or about the security of storage encryption versus the read-only certificates, or encryption in transit, tasks and analyzers and studio configuration, all the rest that can do. This is a great list of, here's some cool features that it does. You can look through and kind of expand your knowledge about RavenDB. Also notice in here that the cloud pricing has a really great configuration tool that allows us to configure for any of the portals or any of the cloud providers and see how much it is per hour or per month based upon our configuration down here. Also note, there's also a version for serverless. This is great for if you have a low usage usually, but every once in a while you have a spike. That spike's going to cost you more, but the rest of the time you're paying the least amount. So that can be really great. Just be careful you don't have too many spikes, otherwise it gets very, very expensive. So the other thing is, if you're on AWS, there is a free tier. It's not on Azure or on Google, but it is on AWS. There's a free tier. It's just for testing purposes. It's not for really production use. I mean, you technically probably could, but it is restricted to community license. And that's one more thing I want to point out is back in the licensing page down at the bottom, there is developer licenses, which are free. You just can't use them in production. There's a couple other restrictions, but that's the big one. And then also the community license, which is free as well. You can use it in production. It just requires that you stay on the latest major version of RavenDB, and you're limited to 60 cores per customer entity. That's a core is a number of a part of a CPU. So, and the license is valid for 1 year, but you can renew it. So that's community license. It's typically for getting started in production before you move up to, I guess, more of a real license, more of a professional or enterprise license, depending on your usage. Okay, that's RavenDB. The big one here, though, is docs. Docs are great. Definitely dive right into these and learn more about, well, everything. But for us, what we're going to do is we're going to jump into code, because I think that's important. But one last thing, we're going to write code manually. But if you're using Codex or Claude Code or others, you may be familiar with Context 7, but this is basically an MCP for documentation for a whole bunch of different tools. And RavenDB has official docs on here for working with RavenDB. Now, I would always encourage you to only use things from Context 7 that you trust. My personal opinion is, if you're going to use Context 7 at all, then you should have a whitelist only, meaning it only works on the whitelisted items and not anything else. That way nothing can slip in there accidentally. But there are documentation entries for RavenDB, and these go right to the docs. So here's a repo of the latest documentation. That just makes sure that your AI tool has the latest documentation, and make sure it does the latest, most modern way of doing things. Okay, let's jump right into code. Here I have, let's even get rid of this. This is a console app. It's .NET 10. This is going to be our demo, our first demo for working with RavenDB. But you might say, well, Tim, how can you write C# code? We don't have a database yet. You're right. Let's create one. And to do that, I'm going to run this Docker command. Now, I want to talk through this Docker command because I think it's important that you understand what's going on. If you're not familiar with Docker, I would really encourage you to get familiar with Docker. I have other videos on this, but essentially this is a way to get a database up and running on our machine in a way that we can use it as long as you want, but then we can also just destroy it. And it's not going to hurt anything. It's not going to install DLLs on our machine or have to have updates. This will work just as is. If you ever wanted a newer version, we just delete the current one and restart it. So this is going to run in a disconnected mode, a container, where I call it RavenDB. And we're going to restart the container unless stopped. So that means if we restart the PC, it will restart this RavenDB instance again. The only port we're mapping is 8080. You can change that if you're using port 8080 for something else. You can change to whatever port you want. And then there's a couple of arguments. Setup mode equals none. The security unsecured access allowed equals private network, essentially saying, hey, on the private network, we can access RavenDB without any type of security. That's so we don't have to install certificates for our dev box. And then this is just using the latest version of the RavenDB image. Now, one thing I'm not doing is I'm not including a path or mapping for a local drive. So all the data will be stored in this running container, which means if I delete the container, my data goes away. And that might not be what you want if you want to have a long-running dev database. So you might want to also store the data in a place on this drive and then map that to your local PC. That might be something you want to add, but for me, I don't want that. I want everything to go away when I shut down this instance. So I hit enter, and if you have downloaded already the database or the image, then this is all you get. It's already installed. It's already running. That's it. It's all it took. It's now running, which means we can come back over here to our browser. We can go to localhost 8080. And this is my RavenDB server. That's it. We're done. It's running. So let's take a peek at a couple of different things here. One down here, we can look at the license information. There's no license currently on this server. So it's not yet part of a cluster. It's in a passive state, and it's not licensed yet. So we can get a free license. I encourage you to click that button. I'm going to register my license. Notice down here it has a comparison, etc. I'm going to register my license. I'm going to paste in, I'm going to do it off camera, but I'll paste in my license that's free. I have the free community or developer edition. Okay, I pasted it in. Now it says developer license, not for production use. So that's totally fine, but now I'm licensed as a developer edition. And I'm using the latest version and all the rest. Okay, so now we can come up here to databases. We have no databases. What does it take to create a database? Well, just saying demo DB. There's a database, right? We can quick create, but let's go through next. This is the idea of replication and sharding. Typically for a database, you want to have replication number of nodes is probably 3 at least, and then maybe sharding as well, depending on if you need it. And again, there's what is sharding right there, which is great. So we're not going to do that because we're in development. This is just about creating something we can work with very easily. So we hit next, and then the data directory. Again, if you were mapping your data to a place on your PC through Docker, then you might want to come here and pick where it goes. Otherwise, just keep the box checked, and we'll put it in a space that it's used to putting it. Hit finish. Done. We have a database. So now I can look at this database. I can click on DemoDB, and it goes right up here at Documents. Now, RavenDB is a NoSQL database, which means it's a document database. Now, it does more than that. It does multimodal. It does, time and all the rest. But a document means basically a JSON object. You can think of it that way. It stores it differently, but that's basically what we've got going on here. Right now, there's none. So you don't structure, you don't set up tables, you don't set up, the structure of, okay, these are the columns we're going to have. You do that through the objects you put in here. So right now, there's no collections, which would be basically, think of it kind of like a table in SQL. There's no collections yet, and there's no documents, which think of those documents as a row in a SQL table. So let's get started, I guess, right? Let's do it. So we're going to minimize this and come back over to our program. We're going to go to dependencies. We're going to say manage NuGet packages, and we're going to search for RavenDB. And the first option here is RavenDB.client. This is what we need to connect to a RavenDB database. So we hit install, accept, done. All right, so now I can start connecting to the database. The first thing I need to do is set up a store. So using iDocumentStore, which control dot to add a using directive for that, which it's not doing. I don't know what. Oh, probably because it doesn't realize I'm not using a using directive here. Let's just type it out manually. Using raven.client. Wow, if I can spell right today, right? Using raven.client.documents. And then we'll also just add this here since we're going to need it, using raven.client.documents.session. Okay, so iDocumentStore store equals new document store. So the first thing we need to do is create a document store. So this is something you do once. You don't do it a bunch of times throughout your application. This is once per lifetime of your application. So what goes into this? It's very simple. We're going to have URLs, and this is going to be an array. So let's just create an array, and we'll say HTTP : // localhost : 8080. That's our database. If we had multiple nodes we're talking to, multiple URLs, we put multiple in here. And then what's our default database? This is going to be DemoDB. Now notice I use all lowercase. Doesn't matter. Even though my database that I created, I use capital D and capital DB, it doesn't matter. You can have all lowercase. And then conventions. And we're going to say no conventions. Cool. So that's all we need for our store, except for one last step, which is store.initialize. Now, I want to say at this point that I am writing this code in line to show you how to do each step. However, we're going to go back through and redo this code so that it's more in line with what you would do in production. Okay, so this right here is demo code. I'll make it better demo code for you after we learn all the different CRUD actions. Also note, you can get all the source code in a link down in the description. All right, so we've initialized the store. This is not creating an open connection to the database. This is just setting up the fact that this is how you connect to the database. It's information, it's not a open connection, but we need to have this set up once. All right, now what we need to do is we need to create a new object. Let's Control-Shift-A, and we'll say, let's go with user model. Let's go with user first, or users. Now, I'll explain why in just a minute, but we're going to say namespace is all we need, and then mark this as public, and I'm going to create 3 properties. The first one is string, a nullable string called ID. And then we're going to have a nullable string called first name. And then we're going to have a nullable string called last name. Really simple, right? Now, I called it users plural, which is not what we do normally for a model. But I want to show you the reason why. So this is going to be a mapping thing when it comes to storing records. So I am going to add now a using, which, by the way, these are 2 different ways of doing using. So this right here is just a shortcut. This is just saying, hey, instead of typing raven.client.document.iDocumentStore, just type iDocumentStore. This right here is opening up a kind of a loop. So what this is saying is, hey, I want you to open this store, but at the end of this area, wherever you're in, whatever the context is you're in this case, program.cs, at the end of this, I want you to close down store properly. So do the dispose method on that. We're going to do the same thing here for the iasync document session called session. We're going to say equals store.open async session. Okay, so we now have a session open. Sessions are short. They're only open long enough to do one transaction's worth of things. So you really don't want to have sessions open long running. You want sessions to be really short, open for a little bit, and closed back down. Now, I'm going to leave a session open for the rest of program.cs. Again, this is the demo version. We're going to kind of redo this in a minute. Okay, so what do you want to do with your session? Well, I'm going to say await session.store async and say new users. And I'll say, let's go with first name. Whoops, I have to have the using directive here. So using RavenDB demo because we're in program.cs. So first name equals Tim and last name equals Corey. Now I didn't add an ID. Okay, so this is going to store one new user in the users collection. But it's not doing it yet. We have to say await session.save changes async. So what this does is we first create a connection to the store. Doesn't actually keep an open line to the database. It just has the store being set up. And then we have the session, which opens a session. But we still don't have a long running open connection. This is where we actually do our connection. So this right here is basically queuing up changes. And then right here, we save those changes. That's where the actual data gets transmitted across the wire to our database. So just to be clear, right here, we open a brief connection to the database just to set some things up, but it's not a long running connection. Then here, we don't even do that. We're just waiting. Here, no connection. It's only here that we actually open up that connection, talk to the database, and then close back down. So right now, we have created an insert statement, essentially what we're doing here. So we've taken a model, which I created inline, and we're going to store it async, and this is where we actually save it. Let's just run this as is. So we run the application, should pop up. It should be done. It's done. So now let's go over to our database. And if we come here to documents again, we'll see users/1-A. We also have a collection down here called users. And notice first name Tim, last name Corey. So if we click this, here is the document that we just inserted. We have first name and last name. Notice there are other things, the metadata. It's collection of users, and the CLR type is RavenDB demo.users from RavenDB demo. So we can just ignore that as information we don't need to worry about because it's grayed out, showing us that it's just metadata about the object. But this is the data we sent to our user. Notice there's no ID. That's up here. And this can be used to identify our user. And notice the convention here, users/1-A. And what that's saying is this is the first ID in the user's collection, and it's on node A. So that's going to be the structure for how you get IDs. It's not kind of the same as what you might see in other places where it might be a GUID, which you can do if you want. And you can also specify your own. So let's just do that real quick. I'm going to comment out. Let's Control D here first and duplicate this. And I comment out this one. Actually, I'm going to do this twice. So duplicate again. So let's do, why not, SUSTORE. But we're going to do SU a bit different. We're going to say ID equals, and let's put a comma here. So instead of saying we want to have an ID that's just whatever. We're going to say users, and then I'm going to say pipe character. What this will do is it will generate a number that's going to be, so it's going to say users slash, not pipe, slash, and then a number, not 1A. It's going to say like 2. So this just says, hey, I want you to use an ID after the slash, or in place of the slash. So the last one, let's do, how about, let's stick with Tim, but last name of Smith. And again, I'm going to put an ID here, but this time I'm going to say, you know what? I actually want it to be T Smith 85235. Okay, that's the ID I want to use. Cool. Let's run this again. All right, we're done. So let's go back to our database, go back to our user collection. Notice we now have user /1 because 1A is different. So /1, that's Sue Storm. And if we come back here, we also have T Smith 85235, which is the ID of Tim Smith in this collection. So you get to choose. If you want to put a GUID here, you can generate a new GUID, not a problem. You can do whatever you want for the ID, but just note that if you don't specify anything, it uses this convention. If you specify the collection name in a pipe character, it uses just a numeric designator after that. Also note that I kind of glossed over this, but if you see in documents, there's 4 documents, even though we've created 3. One's called Raven/Hilo/users. Seem to indicate that it has something to do with the user collection. If we click on this, you'll see that max of 1. What this is doing is that since we are generating documents with an ID number, that what it's doing is it's keeping track of that. So it knows what the next document number should be. You don't have to worry about that. It's when it says @system, just means ignore me, leave it alone. Okay, so now notice it created the collection called users. Where did I specify that in my code? Well, I didn't. I just said, hey, store this document. But what it did is it looked at the model and said, oh, users. Therefore, you want that to be in the users collection, which, yeah, makes sense, but at the same time, it doesn't, because it depends on how you want to structure things, right? So I might say, you know what? I hate this. I don't want to call it users. I want to call this the person model. And let's just rename everywhere to person model. And let's even do it here. So now person model, I can undo this, by the way. And because it's commented, it didn't rename it here. So this is going to be the same thing. If I run this app again, it should be done pretty quick. It goes, hey, wait, I've got a problem here. This T Smith 85235 from users to person model isn't supported. We got a problem. That's because it's trying to save this third object, and it's the same ID as another one. This is why typically we see the name of the collection and then a slash, which here's going to be a problem too. So let's say person model. So let's call this 6, right? Which is why you don't want me to do this manually. So we might even want to say, you know what, instead of doing this, let's do, GUID dot new GUID to string. So create a GUID right in line. That'll solve that problem. Okay, so now if you come back over here first and look at our collections, so all documents, notice that we don't have another document, right? We don't have a document for, we have person models, we have this Hilo, which says 1, but we don't have any records for the person model, nor do we have a person model collection. And the reason why is because of how this save changes async works. Save changes async, what it's going to do is treat this whole thing as a transaction. If you're not familiar in database lingo, what that means is that it all succeeds or all fails. So if you write the first 2 records, but the third record causes a problem, like we saw, then it's going to roll back those other changes. That way, for example, if you were saying, take $100 out of my checking account and put it in a savings, that'd be 2 actions. But if you took the $100 out of checking, but didn't yet put it in a savings and the thing crashed, well, now your $100 is missing. That wouldn't be okay. That's why we have transactions that say, no, the whole thing has to work or the whole thing has to fail. This is part of the ACID test for databases. And it's one that RavenDB supports. So now we've fixed all of that. We can run this again and it should work. It does. So now you can come back over here. We can see we have person models collection. Notice we have our GUID here for Tim Smith. We have person model /1 for Sue and person models, because I spelled this model and this one is models, as 2A. So this is a bit better, but now it says person models, and that's not a great collection name. I want to have it say people, or I want to say users. So what do we do about this? Well, there's a way to make this better. By the way, you can come through and just say, you know what, delete everything, or you can come to collections and delete the collection and so on. I'll show you how to delete in a little bit, but this is for testing, right? You can create lots of test data. So right up here, conventions. I'm going to show you a convention that will make life a little bit easier for you if you would like to use it. So let's bring us down to a new line. And in here, I'm going to say find collection name. I'm going to say type and then the arrow, and then we're going to have curly braces. So in here, what we're going to do is we're going to say var name equals type dot name. And what this is going to do is get the type of the object you're storing in your collection or using with your collection. So in this case, person model. And that's going to be right here, person model. We're going to put that into name. And now what we're going to do is we're going to say for each, and we're going to say var suffix in new, and we'll say, actually, I'm going to say, do it this way, in record and model, like so. So what this is doing is we're going to loop over these two. No target type, of course not. So what we'll do instead is just do what I was going to do in the first place, new, and then close that out and make these curly braces. There we go. So what this is going to do is it's going to loop over these two options right now. We can have more later, but these two options and say, hey, if it ends in record or if it ends in model, here's what I want you to do. I want you to say name equals name, and then we're going to say dot dot and the caret, and we're going to say suffix dot length. And what this will do is, or I say break, meaning we're done with the loop. What it's going to do is say, right now we have person model. Well, if we find model in the name, which we do, then we're going to trim off the model. Okay, so we're trimming off all the characters for the length of, in this case, 5. The last 5 characters get trimmed off, which means it's going to say person in here instead of saying person model. If it's person record, it is the same thing. So whatever your default extensions are that you use for your models, if you said DTO, you can throw DTO in here as well. Now that I have that, what I'm going to do is I'm going to say name equals name switch. And then I'm going to say person. So if it says person, so person model is now trimmed down to person. If it says person, I want you to say people. Otherwise, so that's the discard character, meaning anything else. I want you to say name plus S. And I want you to return name. So what this is doing in this find collection name is that we have a convention now that if you pass in person model, it's going to say, okay, trim off model. And since it's person, I want you to translate to people. That's the plural version of person. And return people. That's going to be a people collection. Now, what if you had a user model? Well, it cut off model, and so it's now just user, and user is not person. So it's going to say, okay, just put S at the end. So now it's users. So those are the collection names. So this right here makes things a little easier for making sure your conventions match. If you have other pluralizers to do, you can do that right here. So if there's other ways of, other models you find that don't just pluralize by putting an S at the end, you can modify them here. So without changing anything else except for this find collection, let's run this again. We're done. We can come back to our object and notice, wow, I have a I have a problem because it looks like I'm missing one character. I see the problem. So I do this every time. And so it's going to look through record and say, okay, on the record for each, we're going to just trim off record. That's not what we're supposed to do. Let's cut this out real briefly and say if name.ends with suffix. That's much better. Knew I missed something. So if it ends with the suffix record, then trim it off. If it ends with model, trim it off. The cool thing is, again, demo, we can just run this again. And what it's going to do is now we have the persos collection, but we also have the people collection now. And there we go. Now notice person model /3. That's because we are manually setting what the collection name is, which is probably not the best idea to hard code that. But we'd say this is the people, like so. And now that should insert more properly. Let's run this again. And it's going to now have 6 records, which are basically 3 duplicates. It does. Let's hit the refresh button here. And now we have our information. But now Sue Storm has people /1. So you can do our IDs a number of different ways. I don't recommend that you have IDs of different structures. Personally, just don't include the ID. And it will take care of it for you. It will handle setting things up properly. That's what my recommendation is for you. So now we have data going in. We can make these better if we want by cleaning up how they work. But let's move on to different actions. So let's comment out all of this because I want you to have the code, but we don't want to keep inserting every time I run this. And what I'm going to do is I'm going to say, let's grab all of the users. And let's actually put up here at the top, we're going to do a list of person model. And we're going to call it people. And then down here, we can initialize that list by saying await. And we'll say, actually, no, I'm sorry. People equals await session.query session. I commented out session up here. I was going to say, why is that not there? Session.query. And we're going to query a person model. And we're going to say to list async. Like so. So we're doing everything asynchronously. I just encourage you, always do asynchronous when talking to a database. We don't really need to have synchronous anymore talking to databases. There's no reason to lock our application up. So this is going to get every person in a list. So let's do a for each, just so we can see it. So for each p in people, we're going to say console write line. And let's do string interpolation and say p.first name and then space p.last name. So nothing crazy. Won't put the IDs on here. We'll just throw a list of all the people. Just so we can see that, yes, it's working. There we go. Tim, Corey, Sue Storm, Tim Smith, Tim, Corey, Sue Storm, Tim Smith. If you have those, we did it twice. So there's 6 records total. There we go. That just read all the people from the list. But you might say, well, yeah, it's great, Tim, but we don't typically just query every record in a collection. That's correct. So let's make this a bit more realistic. So let's put this on a new line, and we're going to say, you know what? Before this, we're going to use link syntax and say where, and we'll say x arrow x dot first name equals Tim. So let's just run this. And there we go. Tim, Corey, Tim Smith, Tim, Corey, Tim Smith. So we've now done a query based upon link syntax, which link syntax works just great. You can also use their own language, but this is super simple to do. It's very C# friendly. By the way, I haven't mentioned this, but RavenDB and the other tooling, mostly all just C# code. RavenDB was built using C# and .NET. So it really is C# friendly because of the fact that that's where its roots are from. Okay, so notice I also didn't have to do a save changes async. I'm not doing any write commands. I'm not doing a read command. So this right here, this toList async is where the actual call gets made. Now you could lazy call this if you wanted to. That's a bit out of the scope for this video, but just note that if you want to save the number of actions you do on a session, which we'll talk about in just a minute. But this just did a query and gave back all the records that started or that had a first name of Tim. Now I want you to pause for a minute and think about this. We did a query that filtered the records. How did it know how to filter? Well, we have auto indexing turned on. Let's go back to our database. We come back over here to the left. We have documents. And we have indexes. There's an auto index called people by first name. This was created automatically for us to optimize how we get the data out. So we made the call. This index did not exist. But then it said, hey, I'm going to need an index for this. It created the index and then returned the data to us. Now, if this was too much data to process, then what would happen is it would give us back just a bit of the data that it had if it was going to time out. Okay, so you can go more in depth in this, but just note these auto indexes are very, very quick. They're going to try and get you your data as soon as possible. Even if I have to say, hey, this is partial data, this is all I got, you want to run this again in a little bit once I'm done my index. It doesn't happen very often, especially not when you don't have millions of records, but just know that it can happen. However, I would encourage you to use auto indexes in development and then use static indexes in production. The reason why is in development, you're figuring out what indexes do we need. And too many indexes can cause performance problems. So let's figure out which ones do we need. But once you understand what indexes are best, then you can come over here to advanced and say, I want to convert to static. And this will convert to a new static instance. Here's the syntax for it. It's already done for you. You could have configured it if you wanted to, but this is going to give us the information that we need. So that's an index, but notice there's only one. Let's go back to our code and change this to say last name equals, let's go with Corey, and run this again. And it gives us back Tim Corey twice because there's two Tim Corey records. Let's go back to our database. We now have two indexes. The first one by first name. The second one is by first name and last name. Hold the phone. Why is it that we have first name and last name for the second one? And by the way, the other one just went away. I didn't do anything. It was not a camera trick. It just went away. Why? Well, because RavenDB said, wait a minute, I can optimize this. There was one query that asked for first name. There's a different query that asked for last name. What if I create a index that indexed both first and last name? That way, we have one index instead of two, and we can ask for either one. So it's really intelligent on how it creates these indexes. This is why you want to set up leave auto on in development mode, because it will figure out the best indexes for you and get rid of the rest. Then when you're done and you're ready to go to production, you can just say, hey, mark all these as static indexes. Because that way, they're already set up, they're already indexed. So the very first time a customer asks for that data, it's already indexed. It's very, very fast to get the data back. So best of both worlds here. In development, auto index is on all the time. In production, I'd prefer you do static indexes just because of the optimization of already having them indexed when the first customer asks for that data. So that's auto indexes. Great stuff going on here. All right, back to our people list. We still have a 6 there. Okay, let's look at doing some more things here. Let's look at changing data. So right now I have this for each, and let's change it back to first name equals Tim. And I want to say, you know what? Yeah, let's print it out just so we can see that we have the first name equals Tim, but I want to change the first name, p.first name. I want to change it to Timothy. So I've loaded just the Tim records, but I want to change that first name to Timothy for all those people because that's the more formal full name. Now, this is just a demo, obviously. But I'm going to say down here, await session.saveChangesAsync. Now, again, to be clear, all I've done is changed the loaded list of people. I've changed some of the data. Now that I've done that, I just say save changes. Why? Because since the session is still open, we're tracking the changes on this list of people. And so it says, hey, you know what? I saw that a couple of records, 4 of them to be exact, we changed the first name property. So I'm going to send in the save changes async, not the whole record, but just these changes to just these 4 records. And we're going to do all of that in one query here. Okay, so I run this. It's going to list, and notice that first it says Tim, Corey, Tim Smith, because we did the console right before I changed the value. I didn't do it after because, yeah, of course I can change a list after. But let's go look at our data. And if we hit refresh here, now notice they all say Timothy instead of Tim. All those changes were made all at once, and I didn't have to do anything special. I didn't have to write an update query, anything crazy, because it's just done. Now, I do want to point out one more thing. Let's do this. Let's change this to say Timothy and change it back to Tim. I want to make this change again, but I want to come down here. I want to say console write line, and we're going to say session.advanced.number of requests. So after we save these changes, I want to capture how many requests did we do on this session object. So we've got this load person. We're changing 4 records. And how many requests do you think we're going to do? Okay, let's run this. 2. I've done 2 requests to the server. You might say that doesn't make sense because we loaded all the people. That's 1 request. And then we changed 4 records. Yeah, but that's not where the change happened, remember. The change happened right here. And so what happened is, yeah, it made those 4 changes, but it bundled it all up as 1 request and sent the whole thing over as 1 request. We're working with sessions. You want to try and get the number of requests as close to 1 as possible. It can do about 30 changes or 30 actions or requests in a session. And you can actually change that number to be even more if you were crazy, but you can do that. But you really want a session to be a very atomic action. You don't want it to be lots of actions. But notice this wasn't lots of actions. This is 1 action. So the number of requests, you want them to be pretty small, okay? But in this case, doing these things, only 2. All right? Now, let's think about other things that we might want to do. We've had the create, we've had the read, we've had the update. The last one we need to think about is, well, how do we delete? Well, let's do a delete. So we're going to comment out all of this. And I'm going to come down here and I'm going to say, you know what, let's say that people equals await session dot query, and we're going to say person model, and we're going to say to list async. So that gets the list of all the people. We're going to say for each. We're going to say var p in people, and we'll say, let's go with session.delete P. And then we'll say await session.save changes async. Okay, so I've loaded the list of all the people, and then I call session.delete for every person in the list. And then I do save changes. How many requests do you think that's going to be? Let's actually uncomment this out. 2. Why 2? Well, we load all the people, we delete all the people. 2 requests. If you go back to our database and look at our collection for where's people, it's gone because there's no objects in the collection. If there's no objects in the collection, it's just gone. So we're done. Okay. Our index, well, that index will go away soon because there's no entities to index anymore because they're all gone. Okay. Let's do this. Let's just get rid of everything. I'm going to say delete and hit delete. Oh, that was my bad. I should not have tried to delete the high-low entries. That's my bad. But otherwise, we have our system collection for high-low. Otherwise, we have no collections anymore. That just kind of cleaned things up for us. Ignore all the rest. Okay. So now we've done the full CRUD actions. And I think at this point, you have enough to get started. But I'm going to come back and make this better. But first, I want to talk really briefly about a couple other things that you can do. So we're not done the code yet. I want to come back and make this a better version of our code, but I want to get to some other things you can do with RavenDB. Let's bring back up RavenDB's documentation. There's lots of stuff in here we can talk about, but I want to talk about a few things. The first important one is that you have a search, and let's search for Aspire. And this guide right here, this is a great guide. Okay, it's going to tell you step by step how to work with Aspire. I don't have time in this video to get to it, but if we look down here, it's installing the packages. It shows us step by step how to do that. The only one real kind of quirk is that you have the explanation and then the picture. So if you don't scroll down far enough, you might miss the fact that the picture kind of points out what's going on. So here's a code for Aspire. This right here, add RavenDB. That's what you need to do, and then reference it somewhere for referencing it in your project. And then down here, here's actually setting up a connection to a database. And then down here, this code looks exactly the same as what I've been doing, right? It's just creating new objects and doing store async and save changes async, etc. So setting up an Aspire, super easy to do. And then over here, I do want to point out that there's a lot of information in here, but if you do a search, you can look for things like time series, super fun to do, attachments. You can attach documents to your collection. Really great. There's also 2 different ways of tracking changes. So there's the changes API, which again, if we search for this, changes API. The changes API is for, and here's code for how to do it and how to unsubscribe. The changes API is for tracking changes to your data, where it will say, hey, data in this document or whatever else you're tracking has changed. And this is for like if you want to have your UI refresh every time there's new data in the database without having to constantly pull the database. This will do it. That's what the changes API is for. It's kind of for UI refreshes, etc. There's a different one though, and I believe it's a link in here at some point for the other one right here, data subscription. This is something different. It's like the changes API, but this is another way to monitor for changes on objects or on collections, etc. But what this does is it's more like a queue where, let's say every time you get a new record in a collection, you want to, maybe it's a record for, hey, I want to make this purchase. And so you want to do some processing, like send a message to the warehouse. Well, you could have a data subscription that says every time a new record comes in, I want to do this work. And this will make sure that one and only one system processes every record that comes in or whatever your setup is. So this is more like a queue process. There's also clustering built in. There's more information on Gen AI that you can go into and how to use Gen AI to do things like translate your documents or when they come in, or taking the attachments and then breaking it down into information that can be put into your document, and so many other things. So lots of stuff in here that you can do that I can't get into in this video. I want to cover so much of this, but I want to give you a good intro. That's why I wanted to at least get through this much of it with you. So lots more here. Definitely go and check it out. But let's get back to our code. And if you want to be done right now, cool. Download the source code. There'll be more source code that you've seen so far. We're going to rework this into a more, a better usable at least in development, if not production code base for a console app. It's going to be the same code or close to the same code, but I want to show you how to basically do this better than this demo. Okay, so let's create a new project. We're going to call this a new console project, and we'll call this Better RavenDB Demo. And yes, .NET 10. And we need to bring in that same dependency. By the way, you can look at the dependency right here in your project. We can just copy this if you wanted to. Come over here to our other project and paste it in. We'll do a lot of copying and pasting in this because we're trying to just rework how we've done things. So let's next create a new model. And we're going to call this employee model. I just want to create a different name. That way we don't have the same name kind of step on toes of the two demos. And I'll make this public. And I copy and paste the person model. It's the same data. Okay, it's just a different name. That way we, again, don't step on each other's toes. So there we go. We've got our employee model. And now what I'm going to do is in a Better RavenDB demo, I'm going to create a new object called data access. And we'll get rid of the using directives here and mark this as public. And what we're going to do is I'm going to actually bring in those two, these two right here, these two usings, and put those at the top. This way we have them. Again, makes life a little easier. And now I'm going to create a, let's do constructor. I'm going to mark this as private. So we're going to create a singleton of this class. That way we only ever create one document store. So we're going to say right here, private iDocumentStore. And we'll call it store. And then we're also going to have a property called a static property, a static data access, and we'll call this instance. And we'll not have a setter, we'll only have a getter, but we'll have a default value of new. What that does is the very first time I call instance, it's going to instantiate the data access. This is private. It can still call the constructor. But after that, we call instance, and it just gets the value. So that way we only have one instance. This is a singleton pattern in .NET. Now let's go back to our program.cs, and we're going to grab from store, not the using document store, but from store down to here. We'll grab this whole thing, and we're going to put that in the data access. And we do need to also stay, let's tab to adapt code. That should be formatting our code properly, but looks like it's not going to without some work. So let's just hit tab here and bring that in. Okay, we do need to have our store.initialize. Okay, So this is create a new instance of a document store and putting it into our iDocumentStore. But one of the things you may have noticed, hopefully you did, is that down here we had this as a using statement. So it said using iDocumentStore, which means that it automatically closed out the store when we were done with program.cs. We were done with that scope. We're not doing that here because we can't. We can't close it out at the end of this scope because that's the constructor. So what we're going to do instead is we're going to mark our class as iDisposable. And if you're not familiar with this pattern, what this pattern does is it allows us to make a using statement against this class itself. Now let's collapse down our constructor and we'll come down here and we're going to say public void dispose. Now this is going to fulfill the contract of iDisposable. And inside dispose, we're going to say store.dispose directly. So normally I would not recommend doing this. Don't call store.dispose itself. Just use the using statement, and that way it makes sure it calls that dispose method properly at the end. However, we're doing our own iDisposable, therefore we call this dispose in the dispose method. Okay, now we'll never call this method directly. Again, kind of like this, we're not calling it directly. Instead, what we'll do is in our program.cs, what we're going to do is we're going to come over here and we'll say, first of all, add a using directive for better RavenDB demo. And then we're going to say using data access. We're going to call it data access equals data access.instance. So this right here will make sure we close down or call the dispose method on data access when we're done our scope, which is back to being program.cs. Okay, so this is a better way of doing things to make sure you can do this wherever you're instantiating or setting up your scope. If you're doing dependency injection, we would do it at that point and let dependency injection handle the processing of the dispose method. Okay, so now we can come back over here to our data access. We can start doing work. So we have the setup. We've done the private constructor that has our document store. We have our dispose to properly close the document store. So now let's come down here and we're going to, there we go. We're going to set up some method calls. So public async task of type list of employee model. And we're going to say load all employees. And we're going to make sure we pass in cancellation token equals default. Okay, we're going to use cancellation tokens. That is the recommended best practice way of doing things. When you're ever making an async call, to pass in a cancellation token. That way the call can be canceled properly. So we're going to say, but this also sets it as a default value if it's not being passed in. All right, so using iAsync document session, we're going to call it session equals store.open session async. Where am I getting this from? It's like we're doing right down here, okay? But we're going to be doing it in this method. And in fact, in all these methods, we're going to open up a session. Again, sessions should be atomic. They should be small. They should be doing probably one thing typically. And we're going to say return await session.query employee model to list async and pass in that token. Okay, so now what this load all employees does is it loads, well, all the employees. And notice this session is going to only live for the scope because it's using. So therefore it ends right here. Now, let's follow the same pattern and say public async task of type employee model, and look at nullable model this time. And we're going to say load employee by ID, string ID, and cancellation token equals default. Now we haven't done this previously, load by ID, but we're going to see how to do that. So we're going to open up our session, and no, do not abstract this away. This should be in every single one of these. Don't try and pass it off to a different method or something else. Do it right here. Too many people think that dry, don't repeat yourself, means you should never have repeated lines. That's not what dry means. Put your using statement here for your session. Make sure that you are opening up a new session and having it close at the end of your scope. Don't make a mess of this. Just retype it, or in this case, copy paste. Return await session.load async employee model, and pass in the ID and the token. Now, this load async is going to return an employee model, but just to be clear here, load async is not null aware. That means it could return null. So even though it doesn't say load or employee model question mark is the return type, that is the return type, because it's not null aware means it hasn't been set up yet with the null markings like we have here, but it can return a null. Therefore, we should have it be a nullable aware employee model that we're returning. Okay, so there's the load one. We're going to call all these in a little bit, but I just want to make sure that you saw how to do all these at once. So then we have public async task called insert employee. And we're going to say employee model, employee, and then the cancellation token called token equals default. And we're going to have that same session connection. And we're going to say await session.store async employee and that token. But remember, that's not actually going to the database. That's just basically put it in the queue until we say await session.save changes async and pass in the token. This is where the store async actually gets completed. One note here, this is going to insert one employee. There is a way to do bulk inserts. It's in the documentation. It will show you how to do bulk inserts just in case you want to insert millions of records or whatever when you're first starting up or something else. I'd love to do a separate video on that because bulk inserts is a little bit different, and there can be some tricky things when it comes to resuming broken, when you start doing the upload, but then something happens that breaks. Resuming is a bit different because of how it does the bulk upload. But that's a topic for another day. So we have insert employee. Now let's do public async task of type update employee. And we're going to say employee model employee and cancellation token equals default. And the first thing we do is have our session opened up. And this is where things are a bit tricky. So let's do our await session.save changes async at the end with a token. But in between here, what do you do to update a record? Well, I will tell you what you can do if you wanted to. Await session.store async employee and token. Which you might say, wait, that's the exact same code as insert employee. You're right. But if you had loaded the employee and it had the ID in there, and then you store it async and it says, hey, we've got a matching ID, then what's going to do is it's going to try to overwrite that. But don't do that. And here's why. Because if you do that, your model might not have all the properties of the document in the database. So you might have first name, last name, and ID like you do here, but the database object might also have email address. But if you were to download just the model that you have and then upload it again, you would overwrite the entire document. And then what would happen is the email address will be deleted. That's not a great idea. So here's what I recommend instead. This is going to feel weird, but it's not. var db record equals await session.loadAsync employee model employee.id and token. Now I could have just called the load employee by ID, but I wanted to actually have the code in line and not be confusing. So this is kind of duplicate code, and I would replace this with just calling this load employee by ID. But again, I want to make sure it was clear what we're doing here. Now, if DB record is null, then I want you to throw new exception, and just a generic exception that says the record was not found to update. Now, this load async can load a null object. Notice it's nullable, which means if it's null, then it didn't find the object to update. So therefore, somehow it's gone. So we're just going to say, hey, that's a problem. But if it's not gone, I'm going to say db record.firstname equals employee.firstname. db record.lastname equals employee.lastname. Now, you might look at that and go, oh no, Tim, please don't do this. This is mapping. We don't have to. Here's why. Because we're taking the data that may have changed and putting it into the record that is now tracked. This record right here, even though we got it from a database, is no longer tracked because the session closed. Okay, so if we loaded it from the list of all employees, that session closed right here after it returns the data. So it's no longer being tracked. So you had to get a new record based upon that ID. That's the tracked record. Now we can update that tracked record with the data that we have changed. And now, since this is a tracked record, all we have to do is just say save changes. We don't have to do any kind of updates or anything else. Just save changes. We're done. So now this record will be updated with the new information. Yes, this is a mapping process, and so you have to update this with your mapping. And this is where some people would start reaching for AutoMapper. Please don't do that. Please don't do that. But you can just manually map this over. You could also put in your model a way to map from one model to the other. That'd be a way to do it in the model itself. That's probably the most advisable way of doing that. That way you always make sure that if you change properties, you have right there the mapping that will say, hey, you need to make sure you change this too. So this is how I recommend doing updates. It feels a little weird to load the record and then update the record. You could do some patching if you knew there's only this property or this property is going to change. You could patch it and save it without having to do this load first. But I don't think that's worth it in most cases. So this will do, again, remember the session or the record count, right here, the number of requests. The number of requests here is going to be 2. 1 to load the record, 1 to save the changes. So that is 2 as opposed to 1. You want to get as close to 1 as possible. I think in this case, 1 or 2 is fine. So that's how you do an update record. Again, if you just overwrite the record, that can cause some real problems. I recommend not doing that. All right, finally, we're going to delete the employees. We're going to say public async task delete employee string, just the ID of the employee, and then of course the cancellation token equals default. And then is that still on my clipboard? Yes, it is. Good to go. So now we have our session open. We're going to say session.delete the ID, and then await session.save_changes async and pass in that token. So as delete, pass in the ID to delete, you're good to go. That's all it takes to delete a record. Again, this does not, we're not awaiting it. This is not doing any action. It's just queuing up things to do. This is where the actual call gets made. Therefore, again, the number of calls here is just 1. Okay, that's a lot of changes. Let's go over, and in our program.cs, we now have the ability to make a call to this data access. So let's say await data access dot insert employee, and we're going to say new, and we'll say first name equals Tim and last name equals Corey. Cool. All right, and that's all we need to do. So let's make sure we have this as the startup project, and we'll run this. And we're done. And if you come back now to here, we can come back to our database. We can see employees, notice plural, employees. And we have Tim is 1A, cool. Now let's modify Tim. So what I'm going to do is I'm going to say, we know the, let's say we know what the value is for Tim, right? So actually, you know what? No, let's do a load for Tim. So var employee equals await data access dot load employee by ID. And I think I don't want to guess. I'm going to actually pull it up. I am employees dash 1A. Let's just copy that, which means I messed up my clipboard. That's okay. There's my ID. So we know the ID. We're going to look up the employee. Now we're going to say employee dot first name equals Timothy. And now we're going to say await data access dot update employee, and we're going to pass in employee. Remember, this is no longer tracked. So we're not tracking this. We're just saying, hey, and I know this could be null, but it's not going to be. We're not tracking this. Therefore, this update employee is going to open a new session. Let's run this. Then it should be just done. And if we come back over here, we'll see that let's refresh. It now says Timothy. But notice, how do I know like a change has been made? Like what change is made? Over here, we can see revisions, but there's no revisions. Well, that's because we haven't turned revisions on or revision tracking on. We need to do that. To do that, we're going to go to settings. We're in the database, so we can go to settings. And down here, there is document revisions. And I want to say, you know what? I want to add a collection to track revisions on. So I'm going to choose the collection employees, and the maximum number of revisions to keep 1,000 is a lot. So maybe I do less than that. Let's just keep it down at 10. It's up to you though. The more you keep, of course, the more data you have, although there is compression on this to make sure there's not like a crazy amount of extra data. But we're gonna hit new config, and now we have employees. We're gonna keep 10 revisions. Let's go back to our, status page. Don't forget to hit save. I do it all the time. Hit save on this. Okay, now that's been saved. Now I can come back over to documents, go to employees, and there's still no revisions. But let's change that. So let's go back to our code. Let's minimize this. And you know what we're going to say? Let's change it back to Tim. Okay, and run this code again. The code didn't change, right? All it was, I changed Tim to Timothy or Timothy back to Tim. And now if we hit refresh on this, we see it's Tim Corey again. Cool. So our document has been changed. And notice this orange icon now for revisions. So we click on this and go to revisions. There's 2. If we click this one, it says Tim Corey. If we click this other one, it says Timothy Corey. This is the previous revision. So this is an old revision. This is the new revision. And of course, you want to go back to the current document. You click here, and that's the current document. The current document is always the last revision. So now we have change tracking on our important records. Now, you don't want to do this in every record. Some records just don't matter. but you might want to have change tracking on to see, hey, this record changed and this is the old value. You can kind of roll back changes if you find that necessary for certain records. So that's how you do change tracking. Let's keep going here. You know what? We've got the person in the database, but you know what? I want to get rid of them. So let's do await data access dot delete employee, and we're going to delete employee. Actually, I think I have it pasted or in a clipboard. There you go. And we don't have to pass a token in because we can just say ignore that. It'll use a default token. So run this again. Done. So now if we come back over to our collection, we don't have a collection anymore. All of our documents, they're all gone because we've deleted that document. So that document's entirely gone. Okay. So that's how to use this kind of better way of doing things. This is a better demo, but it was hard to build up over time as much as I did in the original demo. So this is more the kind of code I'd like to see in real applications where it's doing the iDisposable and it's making sure that we have short sessions that only do one thing if possible. And then we make sure that we're calling the using so it closes down at the end of the scope. And we have easy one-liners for accessing our data in different ways. There is so much more to cover with RavenDB, but we're going to end the video here. Don't forget you can get the $200 in cloud credits using the promo code IamTimCorey. The details are down in the description along with a source code download link. Again, the email with the source code will also give you the info on that cloud credit. That way you can just have it email it to you. Thanks to RavenDB for sponsoring this video and supporting the .NET community. And as always, I am Tim Corey.